This is tutorial on how to make a fail-safe, idiot-proof, double rail door operated airlock with proper lighting. So this here is the basic setup that I made, which contains two rail doors. Each have their own detectors and counter detectors, which I will explain later. Each have their own triple colored lights on both ends, and on both ends and in the middle we have a single push button, which creates the easy access of the whole system because everything is operated by one button, or it's automatic to be safe. First, I had to set up in a way that these will be the rails that the doors slide on. I put them on separate sides based on to be able to differentiate which is the outside and which is the inside door. I put rails next to the doors because it looks cool to see the actual workings of the door, and it will not interfere with the doors. These controllers could be way wherever you want it. For example, that rail is controlled by these two, and other rail is controlled by these two buttons when we connect to them. But first, the key point here is that we have a detection on both ends of the door, which will state us if the door is open or closed. So let's dock our door, if I can get around to the leg, to its place. By that, we put the rail docker down, the hotbar. If my computer behaves itself. And we target this rail, and it's up. Now you can see that this activation module is on, while the other one isn't, which is a NOT gate. Also, with this on the other side, and we dock this too. Again, we have set up this as a relay to here, which will represent it much clearly from a standing point of what's happening. So both doors are open now, and they are waiting for connection. This here ought to be the detection of if the if the door is open or closed. So when it's open, it's clearly visible that the activation module is on, so we put it there, and the NOT activation is open because it says it's not closed, it's open. So when both are true, it means it's open. This I will explain later why we need it. On the opposite end, if it's closed, we need to have it closed, and also it can only be closed if it's not open. This is for this side. Let's do it on the other side. If it's open, it is open. If it's open, then it's not closed. Same with the other side. So now we know if those are open or closed, but we still can't control the doors. Therefore, we have to connect the activation button to the proper rails. This tells the rails to go up on this side, but I'm not changing the lower ones because they are only for decoration. Also, this button should change the same 4 rails that we assigned earlier. 1, 2, 3, and 4. Also, on the other side, we changed the 4 rails that it's actually gonna use as a transporting system. And this is to tell it otherwise. My computer is lagging because it's an 8-year-old computer and I'm running in single player. That means the server and the client is running on the same side, on the same computer, and the Core 2 Duo CPU can't handle the load of Starmade. So if I want to close it, I tell it to close it with the other button, and it actually closes, and it tries to go lower. This also shows that it's only open when it's on here. The reason why it can float like that is because I left one more lock missing from the door, which is when I activate the upper portion, it will go up and I can fix the door. The only thing I have to do here is add one more layer at the bottom of it. If I wouldn't have put the rails as decoration there, it wouldn't have jumped around like it did. So this is a good experimentation. Now it also goes down because I have a hole in the floor. Because previously I planned that this side of the door would come from below, but that gives a hard time for me to be able to show the logic on it. So now the point here is that these logics get triggered, and so it will show if the door is actually open or closed. As it is now, it's open. If I send it down, it is closed, and only closed in that position where that is there. Any other position, for example, if it can't close because something is in the way, then it will not trigger, and none of these blocks will have logic, so it will say the door is still in motion, which is good when we want to build a fail-safe door, which only opens one side if the other side is totally closed, or else. So let's do this with the other side of the door, and it might have the same problem that we had earlier, that it closes too far. So I still have to fix this, because of course I miscalculated myself, which happens. And now when I close the door, it closes and stays closed on the exact position it needs to be. But I open it now again. So both doors are closed, are open. No, this one is closed, yes. So I'm gonna open it with the other button. Now, to be able to make this foolproof, I have to create the system which you have here. When you have two sides, then you have 4 cases of the doors, 4 variations of them in combination of being opened or closed. The first one is all doors closed. Second one being one side open and the danger side is closed. The other situation being the danger side is open and the safe is closed. And the fourth is all doors open, which is on an airlock a dangerous situation that should be resolved by automatic closing of all doors. So, the reason we needed the open-close indicators is to be able to program these 4 situations into this essential wiring if-then line. Therefore, what it means, it's written all here, when all doors closed. Thus, this AND module gives a signal to there, and this AND module gives a signal to there, and this then only triggers then. The point here is that we don't want it to work automatically, because then it would cycle over and over and over again like a for loop. Therefore, we need the third option of the buttons to go inside this, so it only checks for the situation when we press the button. Also, for convenience to be able to accessible on all sides, we need to link all the buttons, and we link them recursively, which means this button not only toggles that, but the middle button also toggles the outside ones. This means that every button mirrors the other one. Exactly. So it doesn't matter which button I press, all 3 of them will activate. That makes it the same button in the circuit. Therefore, we can go on with other situations. So when all doors closed, it will open the safe side. We can also test this by closing the doors. When my frames come back to life, this is closed, and we will close this door too. Now both doors are closed, but it doesn't open one side automatically, because we have to press the button to be able to trigger that, which I will put a button on top of here. If I go back into creative mode, when it lets me. After all, this is single player, and you can set your single player to be able to go into creative mode when you want it. So I need a button. I will put a button here, just to be able to show the logic more clearly. So when I press this button, the AND signal on this end lights up. Now the key here is to have a toggle for all the doors. How can I get the toggle? Well, it's actually quite easy. We have a cycle button which triggers either one of these. How do I decide which one of those to trigger? Well, we need an AND block to that. Actually 2, but let's stop there. We can either put a stay signal, which we can put an AND block, 2 AND blocks, which comes from if it's open and the button is pressed, go close it, and if it's closed and the button is pressed, go open it. But we can also have other ways of doing it, for example with a memory slot and a NOT gate. I prefer the ANDs because I don't want my door to not cycle. Which means when it's not closed and it's not open, it will not give a new command to it. Therefore, it will not really break it at all. The button is the trigger for both, because we want the button to be able to trigger it, and we link it down to the appropriate sides. Therefore, when it's closed, this AND signal will give a signal to open the door. But when it's open, I want it to close it on the button press. Therefore, when I press this button, it will open the door and signal that it's open. If I press it it will close it again with all the one button. If I try pressing it while it's inactive, it will not do anything. Therefore, making this a safe button to force tab. So, then we come to our situation that we need to put this on the other side. We have to control the same door. When it's closed, it should open, and when it's open, it should close. And also these affect the buttons, and we need the button for it to be able to work. If I don't put the button in, it will create an infinite loop of closing and opening the door, which is an overcomplicated system of sending it forward and back all the time. Therefore, we need a control to keep it in control. So now we can open both doors with a single button and close them with the single button, and also not make them stop halfway, which is a safe way of operating any rail doors that's connected to an interior air space. Therefore, we can go back to our logic circuit. So, the function of this is to open the safe side. For that, we first trigger a timer block in order to provide function to the lights later. The timer block will go into a flip-flop, which goes into the AND block. Now the AND block is required and will go into the timer block again. Now the key point of this AND block is to know when the actual process has been finished. It's actually the break in the for loop of doing the stuff that needs to be done. Therefore, the job to do here is to toggle the safe side. Thus, when I tell that this button should toggle the safe side, because that's what we want to open. We could tell it directly to open the door, but we don't know if it's closed or not. Therefore, as a second safety measure, we have to be sure that it only finishes when the safe side is closed. I mean, the safe side is open. Therefore, from the safe side is open, I put it into the AND gate. It will tell it that yes, the job has been completed, and therefore you can go along, and we need to link this timer back to the flip-flop in order to reset the whole signal. This shows that when all doors are closed, which means I have to toggle both doors now to be able to close them. When both doors are closed and I press the button, it will open the safe side. Let's check it out. But it didn't send it to the timer block. It does. And therefore, it happened fast. I close the door again, and let's watch it from here. I press the button, the AND signal ignites, igniting the timer block, which cycles the door, which puts into a flip-flop which stays on, which means this means that the actual situation is still ongoing. The AND block checks if it's actually opened, and then it processes forward to another time block which tells that the process has been finished. Let's check it again. Somehow it doesn't fire every time. Now it did. It is because of my lagging of the server. On a multiplayer server, this is much more reliable to do. But when I press it now, it doesn't fire the AND block because the situation is not all doors closed. And our server is under heavy load. Of course, because it's my computer. So let's go further to program the other buttons too. This situation is when the safe side is open and the danger side is actually closed. Look at that, we have the situation right on hand. What do we need? We need the safe side to be open and the danger side to be closed. But we also need the button for it. Because without the button, this would be constantly lighting and would our door be automatic. So what will we do when this situation occurs and we press the button? We want to cycle the whole airlock. Therefore, the first thing is closing the safe side, then waiting, then opening the danger side, then finishing. Thus, the timer block first toggles the safe side, putting the activation signal forward too. And this is the trick part, that the activation signal goes into the AND. Now we have to be sure that the right side or the safe side is closed, therefore we put it into the AND block. When the safe side is closed, the AND block will give the signal to the timer block, which actually cycles the dangerous side, and the cycle will be finished when the dangerous side is open. I could put here another AND block with a flip-flop to actually check if the outside opened, but there is no necessity for that. Because it's a dangerous side, we already sucked all the air out of the system and we don't need to know it anymore. So that is done. Therefore, we should toggle it. It toggles the logic, it checks if it's closed, and it opens the other side. What a nice piece of work. The only thing I forgot to check is to reset the logic. Therefore, I have to create again the situation manually entering, and then it will be able to reset the flip-flop block. Now it only reset it because... And now, first we open it. I said somehow this is not always triggering, but whatever. It will trigger after a while. These things can happen. After all, it's Starmade Airlock. So, let's check it again. It triggers, it closes the door, that resets the whole circuit and opens the outside door. So the logic actually works. The other one is when the danger side open and the safe side is closed, therefore we're coming into the thing. We also operate the middle button because we came into. We have to make sure that that is closed and that is open. I mean, the outside is open and the inside is closed. Then we will trigger the timing block, which will trigger the flip-flop, which will trigger the AND block, which will trigger the timer. Then it resets the flip-flop. The AND signal is also an interesting thing. The timer itself closes the danger and only opens the safe side when it's finished. Therefore the timer opens that. When the actual door is closed, then we go into the end signal to check if it's closed, and when it's closed it gives off the signal to the timer, and that timer will give off the signal to cycle the safe side. And we are almost finished. We only have one more case left. Then we can go into the buttons of the lighting. So the fourth situation is actually the most dangerous situation in an airlock, because when all doors are open, the ship is in danger of losing all of its atmosphere. Therefore, this situation does not require the button to be pressed to be able to trigger the end signal, which means I only input the outside and the inside is open at the same time. And that will trigger the automatic closing of the doors in this timer block, which puts the flip-flop, which goes to end, which puts the timer again. Do we need this much buttons? No, we don't really need this much. The only thing we have to do is the timer will close all doors because they were open, and the end will get only passed through when everything is in a closed position. And the last timer will actually only tick the yellow light, but we get to that later. And it resets the circuit because we want to use it infinite amount of times. Now we can see the danger side is open, but the safe is closed. What happens if I open the safe side and it remains open? It automatically triggers the safety and it will close all the doors it can, therefore protecting everything inside and outside. This prevents any malfunction that the circuit can create because it creates a default state of the doors. And then again, because we set up the first situation, when we press the activation button, it will trigger the timer, which will trigger and open the safe side. And this is a completely foolproof way of making a completely accurate and realistic fail-safe airlock. If any of the logic is destroyed, it will not function. However, the most precious logic blocks are the rails themselves. Of course, if the doors are destroyed, nobody can guarantee safety, so keep your helmets close around. Now, I like to use a free color system as it's generally accepted. The red one for unsafe atmosphere, the yellow one for being in process, and the green one to be able to tell that it's a safe atmosphere to go. I have set up 3 AND blocks, I mean 1 AND block and 2 OR gates to be able to tell which light to light up. I will connect all the lights to them because every light shall indicate every possible situation, and this will make it easy to go. So, when is the green light should be opening? Well, the green light should be opening only if the green door is open. Is that enough for it, you ask? Well, it's not enough because it's not a safe atmosphere unless you did it yourself. That means that it can't actually only trigger when it's online. What I really like to do is putting it somewhere where it's not only that, because if it only comes from that side and I open this side, it would still be green, which would be ridiculous. Because when I open this side and that logic triggers, it will show green light. Of course, when I open the outside one, it will turn off. Therefore, one can put simple measures, and I can put some different logic to put onto the green light to only lit up for a single second, which can be a good or a bad thing. Personally, I don't like lights being all over the place. Therefore, this side triggers the light because it opens the safe side, and this timer opens the light. Now, I can't make it so that both of these situations are existent. Thus, I have to make an OR gate to be able to tell if one or the other situations are there. Thus, when I trigger the block, and it again just with this one, it will light up because I set it up too. But it will only light up for one instance. The yellow light is a bit more tricky. And actually, I missed another block here, but I will not remove it. What I like for the yellow lights is a flip-flop, because we're actually toggling something that should be lit all over the process. Thus we know when the yellow light is on, then the airlock is in cycling or in processing mode. Therefore we shouldn't touch the button. The yellow light is to not touch the button. That means when the process has started, which is indicated by the 4 timer blocks. The timer blocks are not really necessary. Otherwise, I like to put them there in order to give a little delay for the player to be able to notice its environment. So now the light will toggle when one of the processes gets online. The problem is it will stay on all the time. So we have to toggle it off when the processes actually finish. Thus, all the time blocks will trigger the turning off of the yellow light. Let's check it. And again, thank you for lagging. It turned on, it turned off, and the heavy load prevented from the green light to be lit. Yet, it's something to do. So, when shall the red light be opened? Well, it shall be when the dangerous side is turned on. When the danger side is open, it should notify us that it doesn't have any atmosphere on. And actually, this is why I usually don't set up this or this AND signal. I just usually put this activate signal to the lights. Therefore, I'm gonna remove this and only light the green light when that side is open. So we should cycle it. And atmosphere is in because it either draws from the ship or it draws from being able to open it. So that turns on the red light. Let's connect this. To all sides. And so now we have created a completely idiot-proof button-based system, which sometimes doesn't trigger. I can also put this one into this system because it opens the danger side. And we have a completely working system of 2 airlocks with a server under heavy load. Excuse those messages, I don't have a modern CPU. And see? That also did some work, but it changed the red behavior. So it turned on, it toggled. But it already toggled, and that thing came off. So I could put this into a flip-flop and then the red, but I don't see it necessary. And this is all the system that we have here. It will always work, even if a door is obstructed. For example, having a block here, either a ship or a block, although a ship would lag through, the green light is not lit, only the yellow light is letting us know that it's still in cycle and it cannot cycle and it cannot open this door. No matter how much I flip this button, I can panic all I want until I close the danger side. I will not get a safe atmosphere. There are multiple ways of setting up the lights with multiple logic systems in order to make it a little bit more realistic. I just like the simplicity of this. Also, a key point to notice: if I take myself, so how to make this airlock faction friendly? Well, I just have to put one permission block on the safe end and one permission block on the middle end. The outside one can only be toggled by faction members if you have a faction station or faction ship. But everyone can get out of your ship by toggling the airlock from either that side or this side. That will make it possible for anybody to leave your station or ship. However, they can only come in when the door is actually open. The way to close them out of your station or ship is to just close the outside door, and nobody who doesn't have access to your ship or station can open the door when it's closed. Only your faction can. And therefore it's a faction safe, fail safe, idiot proof method of creating a real door system airlock. I put up this picture on our mushroomfleet G+ server, I mean not server but group, and the winner was, I asked them what this logic system is, and Papamaanbear managed to figure out that it's a Fallout style airlock, or door as he written it. Well, he was the closest to manage it, so 10 deltas go to him, which I will deliver somehow. And this was the tutorial about how to make a fail-safe, faction-proof door system by Rails with Lightning. You can put as many doors as you want, you can put as many systems you want, you can have multiple doors on the same side and multiple doors on the other side. It will ask for everything unless you mislink, then it will be always working. Even if a ship pokes a nose through, it will remain atmospherically safe.